So what I want to talk through today is primarily first start off with what exactly it means to be doing machine learning as an engineering discipline. Once we get that out of the way, I want to go through some challenges that pretty much every organization goes through with machine learning as they are maturing. I just then want to talk about a vision that we could all aspire to and how we want to go about executing against that vision. This is based on some of my experiences working at a couple of companies in the last few years, and something that I have really lived through. And I'll also talk a little bit about the execution strategy as well. So the goal really is for you to, what you want to take away from this session is mainly how you could potentially also build a ML system within your organization that is fully automated. So firstly, what is an ML as an engineering discipline? Delivering business value using ML is not just about building a state-of-the-art model. It's also about operating the ML system continuously, as well as the ML system having the ability to adapt to dynamic changes in the business at all times. A real ML system contains or involves multiple things, right? So first one is data collection, processing, and the ability to manage features. Features are data sets that are used by machine learning models. When you are building these models, you also want to ensure there is a lot of quality in them. So it starts with continuous integration and delivery. If you're a bit more advanced, you can look at continuous training. And with some stretch goals, you can go after continuous deployment as well. And I'll talk about how all of these things will come together in the next few slides. Then you want to have this ML system provide training and model evaluation at scale. You want to be able to serve your models both in batch or online pretty easily, just by writing a couple of lines of code if possible. You want to be able to track all your model metadata and artifacts. So you can always do time travel type use cases. And lastly, you should always look at implementing continuous monitoring for both your data as well as model performance. So all of these put together, if you build a system that has all these capabilities, that is when you have a ML system. That is when you're really doing machine learning as an engineering discipline. So now let's talk about the current challenges, which I'll try to address, or how I'm going to address all these challenges with a few slides or strategies in the next few slides. Maybe some of them are familiar to you. If you have a pretty large ML practice within your organization, you will generally have multiple teams. And most of these teams work in silos. What I mean by that is everybody picks their own ML platform, ML capabilities, or ways to access data. And there's really no standardization of how you deploy a model in production. As a result, there's a lot of inefficiencies across the organization. Many organizations don't even have a feature store, which is, to me, one of the main things that a company or an organization should invest in. So we'll talk about how to solve that problem as well. Data, irrespective of what company you work for, you name it, they have data challenges. How far these data challenges go and how crippling they are for you, that's where the difference is. So we'll talk about how we want to improve with data as well. And next, monitoring. Monitoring and operational readiness. Many people release their models into production without having proper monitoring and alerting in place. What that does is basically your model goes into production, you all celebrate, but 2 days later it will crash and burn, and you won't even know. So you have to go fix those problems. So ideally you want to be able to proactively understand when something is not doing so well, either from a data quality perspective or a model accuracy perspective. So you can proactively take steps to prevent any production disruption. And lastly, getting a model into production is a multi-team effort. I often see organizations having a very fragmented approach to collaboration with all these other organizations. So you have product managers, you have scientists, you have engineers, you have project managers, so on and so forth. This is a team effort. and we'll talk about how we could potentially fix this. Now I want to talk about, so I gave you a little sense of what an ML system is, what challenges we are going to try to address. Now let's talk about what is that North Star that we want to go after. So we want to be able to build and deliver a MLOps platform that enables our data scientists to access reliable data. We want to give data scientists an ability to automatically process their data, train their models, and evaluate and validate their models all in an automated fashion. We want to give them the ability to productionize their models for both batch or online serving in a very easy manner. You want to be able to give them the ability to continuously monitor their both data and model performance. And lastly, for auto-training capabilities, you want to be able to use a trigger-based mechanism to auto-train, deliver, and deploy in production. And I'll talk about some of these architectural patterns that will get us here. For you to maybe understand this, I came up with this analogy. If you have a factory that manufactures products, so think of this platform that I'm talking about here as an ML factory, where a data scientist brings their model, and it goes through multiple stages of automation, and finally the product in the end is released. And before it's released, you run a bunch of quality checks, and then the product is ready for consumption. So this is basically what we are going after, giving data scientists the ability to do their day-to-day jobs with almost zero reliance on engineers. That way, you really accelerate a organization's ability to deliver models into production, provide value. Now that we have the North Star, let's talk about how we want to get to that North Star. There are multiple things you have to do comprehensively and systematically for us to be able to hit that vision. I have 6 items that I call out here. First one is MLOps transformation. You really want to be able to streamline and standardize all your productionization processes. You want to just do the same thing. It's a repeat and rinse, rinse and repeat type capability where you do one way of productionizing a model in one team. That's exactly how it is done in other teams. So you really have to drive these standards across organizations. And I'll tell you how you can do this with some patterns that I'm going to talk about soon. Feature engineering. This is another major piece. Data is only your ML model is only as good as your data. And you want to have easy access to these features. I believe in having a centralized feature store, which gives you the ability to both serve as well as train from the same data store. It will also enable you to remove the training and serving skew. This is another major problem in production that most companies run into. Having a feature store that is properly managed will remove that skew for you. Next is data availability. You really want to drive data as a product mindset with your data engineering teams. Data scientists are generally downstream, and data engineering is generally a separate organization, and they are very likely operating in a silo. You really want to break that a little bit and make it. You want to bring that to a place where these data engineering teams are delivering data for you with some SLOs, with some availability metrics like 4 nines of availability, et cetera. And I'll talk about how we want to. I'll talk about this a little bit more. Then data and model monitoring. Like I said earlier, we want to enable comprehensive monitoring for both your data quality as well as model performance. From an operational readiness perspective, you want to address this by following a bunch of tiered support models. What I mean by that is, not every model requires, let's say, 24/7 support. A batch model maybe just needs support during business hours. If it is a real-time model, perhaps you need support 24/7, specifically in the personalization space, where you have search models, you have recommendation systems, et cetera. And last but not the least is executing as a product team. Like I said earlier, A model gets into production after collaborating with numerous organizations. And you really need to work together in ensuring you deliver that use case to the business so it adds value. And you need to have close collaboration working skills. I think some of my counterparts today spoke about how to execute in an agile environment. So that is what this is referring to. Now, those are the 6 models or the 6 goals, if you will, on my previous slide. Now I want to talk about how we want to address each one of them individually. First one is the MLOps transformation. And this is the high-level reference architecture. I like to keep my system design extremely simple, so they're easy to understand. When something is easy to understand and simple to read, that also means it's highly scalable and works really well. So the front and center of my design, like you see, is a feature store. A feature store is central for any of the machine learning capabilities that we want to build in a company. This feature store has the ability to ingest data from numerous data sources. I have a couple of more a couple of more slides which will go into a bit more detail. But at this point, just assume that you have ability to ingest data into your feature store, and this feature store has the ability for anyone to reuse data as well, right? So reuse features. Generally, in most companies, there are some fundamental features that will be leveraged by numerous data science teams. If you don't have a central feature store, what happens is every data science team is creating their own feature. So for example, if it's an e-commerce company, order data, right, or order ID, that's a feature pretty much every data science team is going to use, or a SKU is a, go ahead.
So I think of features as metadata, essentially, but it's more than metadata. It can be abstracted at another higher level, yes? How do you think of
Feature data is basically data. It's not metadata. The feature is basically the data that a model uses for getting trained. And even while serving, if it's real-time model, you're using the data.
As opposed to reference data.
Correct.
It's the data itself.
Yeah, it's actually the data itself. So data that is modified and usable for a data science model is called a feature. Mostly the raw data that you have in your data lake may not be directly usable for data science models. That's where you do all these kinds of aggregations. You create a curated data layer or a feature store. You create aggregations. Features are generally aggregations in most cases. Yeah. Correct, exactly. Yeah. You could always have metadata. Metadata is always useful, but then this is the real data. Features are real data sets. Anyway, so a feature store also enables feature discovery, right? Most modern feature stores built for data science use, they can enable you to search and find out if the feature is already there. Something like order ID, like I said, or SKU ID. These are capabilities or features that are pretty broadly used everywhere. So if you do it once, build it once, pretty much every team can use it. Then one of the another major capabilities of a feature store, it will allow you to serve your model directly from the feature store. It will also allow you to train your model directly from the feature store. And since you're using one central repository, which is the feature store, you are removing any training and serving SKU as well, which is, again, a pretty nasty problem most organizations run into. Then you also want a workflow orchestration engine that is able to orchestrate your data processing pipelines, your ingestion pipelines, your ML production pipelines, and so on and so forth. And that is something that should be available across the board, through various use cases that you see in this pattern. And lastly, your continuous data quality and model performance monitoring. And this is how we are going to drive the standards across the organization by building a shared library. So everything you saw in the previous picture, we won't allow our engineers or scientists to access any of these things directly. You really want an abstraction layer that can enable a scientist or engineer to ingest data, for example, or create a feature in the feature store. Or if you want to serve the model, it should not be more than a couple of lines of code. And all of that can be handled by a shared library. Generally, scientists and engineers unintentionally sometimes they might be running a model with lots of pods, as an example, in a Kubernetes environment or a lot of VMs, because cloud generally makes everything automated. To prevent some of those things, you can build guardrails in how your scientists or engineers use your platform, and those guardrails can be built into your shared library. So it becomes an extremely powerful way to control the access to the platform, but also make it extremely easy for scientists or engineers to do the day-to-day tasks. For example, building an ingestion pipeline or building a ML production pipeline, serving a model, any of these things. It won't take you more than a couple of lines of code if you have an abstraction library built like this. And I didn't even talk about security, right? So getting access to these capabilities, if everybody is, again, doing it without a shared library, it's just going to be a big mess. If you, again, enable all the security requirements for your company through the shared library, you really don't have to keep an eye on what each team is doing. So that's another way. This is how I believe we could have these streamlined and standard processes across multiple data science teams. This is a double click on that screen, double click on that pattern that I shared earlier. As you can see on the left side, you can have numerous data sources. The data source could be your data warehouse, data coming from Instagram or Facebook, or it could be other streams of data, like data from your PubSub or Kafka or any of the other messaging platforms. The idea is you work with all of these data sources, and you build capabilities in your shared library to ingest all of that data in a certain way into the feature store. If it is streaming data, your feature store should be able to support streaming data. If it is batch data, it's easy enough. You can ingest batch data as well. And from this feature store, if you look at the bottom of the screen and then the right of the screen, you are able to serve it in multiple different ways. And each way of serving requires, again, a couple of lines of code if you abstract that away in the shared library. And then you access the data in the feature store through your notebook. So if you're doing exploratory work, and if your data is already in the feature store, you can use a notebook, or you can use your favorite IDE to create your models, and also run your models, or test and train, et cetera, et cetera. Let's keep going. So that's how I believe we do machine learning transformation. If those are the architectural patterns, I suggest that you guys consider if you want to drive some standardizations across your organization. There are 5 other capabilities that I want to quickly go through. First is feature engineering. Feature store, like I said, is central of everything we do within machine learning, in my opinion. So you want to spend quite a bit of time. There are lots of options out there in the market. There is Feast, which is open source. Most of the big public cloud providers have their own feature stores, cloud-native feature stores. And then vendors like Databricks also provide feature stores. So the idea is to leverage one of these custom-built feature stores for data science usage. And you want to evaluate which one of those works really best for your organization, and stick to it. And you want to have a single repository, which is the feature store for both online and batch serving. And always make discovery and reusability a priority. That's one of the main capabilities of a feature store, and that will help reduce the inefficiencies that might happen within the org. Next one is data availability. Build a strong relationship with your data engineering team. Ideally, the data engineering team should be providing you data as a product. What it really means is that the data engineering team owns the data. The data producer, whoever is emitting that first event or creating the transaction, let's say in a database, they own that data, that piece of data they emitted right from the point of emission to the point it is consumed by scientists or analysts or whoever, right? So that way, you basically break this silo data science, or not data science, but a data engineering organization. You are basically making the data producer accountable for their data from the point it gets emitted to the point it's consumed. So if there are changes in the data schema, or if there are new data sets they are creating, or if they want to do some changes that might impact the consumers, they're always going to be giving you a heads up, enough time for you to react. It's very similar to a operating system. If you're getting updates to your operating system, Apple or Microsoft or whoever, they'll tell you, hey, you're going to be updating your operating system, right? And it will give you some time to do that, or your IT department might also do that. It is very similar. If the data producer is emitting data and there are changes to the data, they have to give you enough heads up so you can react to these changes. So that is what a data as a product means. You also want to have your data engineering team or these data producers give you data availability metrics, such as 3 nines of availability, 4 nines of availability, and so on and so forth. If your company is big on streaming, you should strongly consider implementing public topics, which are easily consumable by data science models, especially in real-time serving use cases. Then looking at data and model monitoring, I think I've already alluded to this. Continuous monitoring of your data and model drift is super important for building an automated ML system. One of the capabilities for the data quality monitoring tool should be unsupervised learning and detection of data anomalies and generating alerts for you. There are quite a few products out there which actually do this today. Many companies, including the ones that I've worked at, have implemented their own data quality checks, but it's not comprehensive enough. There are other smaller companies, with very little investment, they can give you capabilities to monitor your data in an unsupervised manner. So for example, if your data sets suddenly have a huge number of nulls, they will be able to alert you. If there are any other anomalies within the data, they alert you. So those are all things that that can enable you to understand what might be going wrong with your model ahead of time, so you can take action and fix it. Similarly, for model monitoring accuracy, this is one way to build a auto training capability within your ML system. So think of a situation where you're continuously monitoring the model for its degradation or its performance or accuracy, whatever KPI you're going after. Most of these tools, again, out there do this for us. As and when the model degrades beyond a certain threshold, think of this alert getting generated, and it goes to, let's say, a messaging platform like a Kafka or a PubSub or Kinesis, depending on what system you're using. And then you have a consumer listening on these topics, right? As soon as they see this topic or this message within the topic, it can kick off your ML pipeline. Since your ML pipeline, auto training pipeline, is automated using that workflow orchestration tool that I was talking about earlier, you can build this automated training capability. So just imagine what this gives you. You have a model running in production. It has all kind of monitoring around it. And then something goes wrong, basically the system is able to react to that change, train the model by itself, and then you run a bunch of tests because you have CI/CD and everything else. And then if the tests pass, the model gets deployed into production as well. So you really don't have to touch anything. I mean, again, this is not so easy as I'm saying it. It takes a lot of investment and a lot of effort for us to really get there. But this makes everything so super automated that it will generate a lot of value for your company in the long term. So something you want to think about. And you have to be very strategic, right? So some of the things that I talked about can help you get there. And the last couple of things, operational readiness. This is very near and dear to me because I've run large systems at Wayfair and other companies in the past. Most people, release the product, and it kind of hurts me without enough monitoring capabilities around it, monitoring and alerting capabilities around it. So you want to build a standard around, raise the bar for your company, for your team, on what it really means to be operationally ready, right? You got to take pride in your model or application running safely in production without any issues. right? So you want to build enough standards or monitoring capabilities before you release something into production. Continuous integration and continuous delivery is another capability that you want to have. This enables you to have enough quality built anytime a change in production happens. Lastly, you could also, if you have lots of models, I've dealt with hundreds of models within the 2 arcs that I've worked at. You want to have a dashboard too to understand how your operational readiness is. When you have a lot of legacy models running in production, you may not even know how ready you are or how much monitoring you really have. So if you have a dashboard where you can go answer a few questions and then figure out what level you are at with each model, it will help you. And lastly, executing as a product team. Look for building a atomic team or a squad, whatever you want to call it, depending on the business you are in, and try to work collaboratively with all of them. Come up with a working model as well, defining each and every work stream's responsibility. For example, what the scientists do, what engineers do, product managers do, project managers or analysts, etc. Whoever they are, you want to define what each of them do and give them one goal to go achieve, like one OKR. And the team wins or I would say, let's say, meets or doesn't meet an OKR as a team. And you empower the team to go reach that goal together and not individually. That will remove finger pointing. With data science teams, when you have so many teams involved, finger pointing becomes very easy. You have to completely eliminate that at leadership level, also at team levels. And you basically tell them you win or lose together. Yeah. In summary, building and delivering a fully automated ML system that is unique to a business is a journey and potentially a multi-year one at it. It's not easy. And your journey really starts with building a vision and getting your stakeholders excited about it or your team members excited about it. And once you have that vision, once you have that North Star in everybody's head, then it becomes all about execution. So you build an execution strategy too, again, very systematically. And once you have an execution strategy, some ruthless execution will really get you to as close to your vision as possible. So with that, I conclude my presentation. I have a few ways to kind of connect with me if you like, and I'm happy to take any questions. Oh, thank you. Thank you, folks. Yes, please.
So fascinating on how you've been able to automate this end to end. I was wondering, what type of time horizon do you see the ROI paying off? It's a multi-year project, expensive, big investment. When do you feel it pays off, and like how should a company decide? Yes, this is right for you. I'm not at the scale yet.
That's a great question, and I can tell you, based on my previous experience, we were able to provide value within 6 months. I don't know how to go back. Can I go back? So the sweet sauce, the secret sauce was the shared library, right? So the fundamental building blocks for this strategy, if you look, is the feature store. What we did was we first went and invested our effort in building this feature store, evaluating and making sure that it actually works for a couple of models and it's providing the value that we are looking for, from a serving perspective, discovery perspective, and so on and so forth. So once we had that feature store nailed, the next step was to use a workflow orchestration engine. We used Kubeflow. And by the way, this was all cloud native. I strongly believe in leveraging the cloud native services just because you get DevOps for free at a reasonable price if you with your favorite public cloud provider. And these cloud native services have an army of people behind them, managing them, building them, ensuring quality and all that. So when you use a serverless capability like that in the cloud, some of this becomes extremely easy because you're not managing your feature store or your Kubeflow pipelines or Airflow instances and so on and so forth, right? So that was another key which enabled us to accelerate. In my past life, we were able to get down the amount of time we spent in productionizing our real-time models from several months to 4 weeks. I don't work at that company, but if I were to, I had a goal of getting that down to 2 weeks by the end of this year, right? It gives you that power. It just becomes extremely easy. Any other questions, folks? Yes.
It's not the most exciting question, but it's rather important. 24/7 support, getting a data science team. Hey, you're on call this weekend, Saturday, Sunday, it's your time. I don't want to do that. How do you get past that? Because everyone needs to do it.
Scientists generally don't do that. And usually when you have problems in production, it's majorly with the pipelines. If you have brittle infrastructure, if your system design for your model is not that great, it will break. And generally, scientists are not the right people, assuming your organization has engineers, right? So I run machine learning engineering at Levi. So my team is the one that goes and fixes the problems. Very rarely, it's a problem with the model itself. The model might have degraded so badly that it needs to be retrained. So if you don't have any of these automated processes, monitoring and all of those, only then you need data scientists. Scientists are not software engineers. So we all have to acknowledge that. They are pretty awesome with building revenue generating models, but they're not so great software engineers. And that's the reason I strongly believe in machine learning engineers being embedded into all these data science teams and doing some of the things that I just talked about. And operational readiness, like you're talking about being on call, these days that's a pretty normal thing. And if you have a proper monitoring, alerting, et cetera, you have proper standards in releasing your model into production, the number of times somebody gets called is going to be very, very less. And like I also said, not every model requires 24/7. So you have to be very, very ruthless in saying if it requires 24/7 support, somebody has to prove to you, especially the business, that it's going to have some massive impact on your business, right? And only then you provide 24/7. Otherwise, you don't. Okay. Yeah, sure. Hi.
The process that you talked about, the seamless process sounds great. Is this something that you have to build in-house, or are there tools that you can recommend that would take someone from training to production to retraining?
So there are a lot of tools out there that give you this ability. If you remove that shade library from this picture, everything else that you see here, any public cloud provider or even something like Databricks will give you. The key here is doing a bit more than what these providers give you, right? So you're already leveraging most of it from public cloud provider or Databricks or Domino Labs or whatever, Domino Data Labs. But you still need, in my opinion, a shared library. And I don't think that's a pretty heavy investment. If you want to streamline your productionization processes, a shared library will go a long way in helping you with that. And that's probably the only investment you want to make. Yes.
Thank you. Do you ever see bias or fairness metrics built into the automated monitoring process for models, or is that uncommon?
Not yet. I don't know the answer because I just did not implement that yet. I've been more focused on things like model accuracy, degrading beyond a certain level, right? So those are the fundamental things I'm going after right now. Bias, et cetera, I haven't gotten to that point yet. But that's a good question. I have to think about it. Yes.
What's the role of standardized terminology? Timothy talked about taxonomies and, of course, with ontologies. Where does that fit in terms of the development? Does that need to be at an enterprise level? The business unit, where do you go? That reference data.
So is your question, if I'm trying to understand about data governance?
It's part data governance, but it's where are you looking? Are you looking to the business for terminology about products and services and so on? Or is that something that you're part of the development of? It's the taxonomies that need to be consistent. What's your opinion?
So anything related to data, it cannot be centralized. You want to make it decentralized. That is the future. That's what I think somebody was referring to, data mesh. If you keep the responsibility, this from a data governance perspective to a central team, I think that company cannot win that easily because they don't have any control on the data that is getting emitted or produced. So you really want to push the responsibility of data and its quality to the person or the team that is emitting it.
Decentralized.
Decentralized, exactly.
Wouldn't you say that would also go with centralized standards? Because that's kind of what you're doing here, right?
Well, so yeah, that's a very good question. Feature store, the feature store, it's think of it like a database or a data warehouse. It's another data store. You want this centralized, or you can even do this decentralized if it works for you. If you are a large enough organization, perhaps you could have multiple feature stores, and you can have some ways of ingesting some of these common features from one place to the other. You can make it decentralized too. I think the idea here is pretty simple, right? I didn't want to go into all those details, but you could have multiple feature stores for multiple teams, and you can build software so the feature discovery and ingesting data from one feature store to the other, all of that happens seamlessly without any knowledge for the user. So there are multiple ways to doing this. And even in this case, feature store might be one box here, but it's horizontally scalable, fully secured, and has really good latency metrics or KPIs to support both real-time and batch serving. So there are all these other things, right? So you have to weigh in what works for your organization. This pattern is just a high-level one, and you can spin it multiple ways. Okay, no problem.
That's a great seamless process. How do you deal with uncertainty in the model development, right? If it's software, you know what's the end out. People have done it many times, you know the timeline, you can't just but whenever you're building a model, there's a lot of challenging problems, and there's no way you can estimate very well the time. Any advice on containing, estimating the timeline, not missing the risk of ML development?
Your question is specific to model development, right? It really depends on your data science team. You want to have high standards, and business is the one which has the ability to say this is good enough. So that's what has worked for me. Understanding what that good enough is. Sometimes an accuracy of 90% in the very first version may not be possible. Maybe 70% accuracy is fine because it provides some value to the business. So having this ability to understand when it is good enough and negotiating with business, getting it into production and start delivering value and building it iteratively, just like how you would with any software development product, I think is the key. There is no easy way to determine what good enough is. It depends on the teams or the business and what you're trying to solve. Okay. Any other questions, folks? Okay, thanks so much.